Assistant Professor from the Department of Mathematics at AJK College of Arts and Science. Today we are going to learn about set theory and types and set operation, Venn diagrams, laws of set theory, inclusion and exclusion principles. So first of all, what is set theory? Set is a collection of well-defined objects. In a word, well-defined means that in any given object must be either an element of a set or not be an element of a set. That is, we say that a set A and B are equal. A set is always denoted by a capital letter. For example, we are considering a set A such that X is in flower. Next, we are considering a set B. Set B equal to set of all X such that X is in vowels in an English alphabet. So next topic is elements of a set. The object in a set are called its elements or its numbers. It is always denoted by a lowercase. For example, A, B, C. If X is an element of a set A, then symbolically we write X belongs to A. Then there are two types of description method in a set. The first type is roster methods and second type is set builder method. Roster build method means the elements of a set are described by listing or writing in an element with its braces. For example, we are considering a set B. B means vowels in an English alphabet. Next set is set builder method. The elements of a set are represented by stating the property that is uniquely characterizes them. For example, we are considering a set A, that is A equal to set of all 2, 4, 6, 8, etc. It can be represented as set A equal to set of all X such that X is an even positive numbers. Next, we are going to look at types of sets. So first, finite set. A word finite has its own definition. A set is finite if it is contain finite number of elements. For example, set of students in a class. And next example, set of months in a year. So next type is infinite set. A set which contains infinite number of elements is known as infinite set. For example, we are considering a set A equal to set of all 1, 2, 3, 4, etc. The set of all natural numbers. Next, we are considering an integers. So integers means all negative numbers and positive numbers and 0 will also be included. So next type is singleton set. A set which contains only one element is called a singleton set. For example, we are considering an A set. A equal to set of all X such that 4 less than or equal to X less than or equal to 6. So next type is null set. A set which contains no element is called an empty set. It is also called as a null set or void set. Next set is equal set. Two sets A and B are said to be equal if every element of A is an element of B and also every element of B is an element of A. It is denoted by A equal to B. For example, we are considering an A set A equal to 1, 2, 3, 4 and we are considering B set 1, 3, 2, 4. So next type is subset. Let A and B are two non-empty sets. The set A is a subset of B if every element of A is an element of B. Symbolically, it can be written as A subset B, which means that A contained in B. The set B is a subset of A if every element of B is an element of A. Symbolically, we can write as B subset A. For example, we are considering an A set A equal to set of all 1, 3, 5 and we are considering a B set of all 5, 4, 3, 2, 1. Since every element of A is an element of B, that is A subset B. So, important points that we need to remember while studying and subset is every set is a subset of itself and null set is a subset of every set. These 2 points are very important points in the subset. So next we are going to see an properties of subset. So first property is, if set A is a subset of set B, then set B is a superset of set A. And second property is, A subset of B and B subset of A, that implies A is equal to B. And third property is, A subset of B and B subset of C, that implies that A subset of C directly. Next is a power set. If A is any set, then the set of all subsets of A is a power set of A, and it's denoted by P of A. For example, we are considering a set A equal to set of all A, then the P of A equal to empty. Next, we are going to see an universal set. The set of all set under the consideration is called an universal set, and it is denoted by a capital U. For example, set of all points in a plane from an universal set. So next type is disjoint set. The word disjoint means a two set A and B are disjoint if we have no common elements. The very important point in a disjoint is it won't have a common elements. That is, your intersection is null set. So we need to remember that A intersection B is equal to empty. So next we are going to look at the topic of laws of set theory. There are 4 types of set operations. First one is union, second one is intersection, third one is difference, and fourth one is complement. So first let us see what is union of sets. The union of two sets A and B denoted by A union B is a set of all elements which belongs to A or to B. That is, A union B equal to set of all X such that X belongs to A or X belongs to B. Simply we need to say means we are having a set A equal to 1, 2, 3, 4 and we are having a set B 4, 5, 6, 7. Now we need to write A union B. Elements in A and elements in B, we need to combine the both set together. Want to write it as an A union B. So next set is intersection of sets. The intersection of A and B denoted by a small letter n. So that is A intersection B equal to set of all X such that X belongs to A and X belongs to B. For example, we are considering a set A as 1, 2, 3 and set B we are considering a 2, 3, 4, 5. The intersection means we need to check whether a set A and B having any common elements or not. For example, here the set A as an 2 and set B as an 2. So your intersection is set of all 2. So next type is a difference of two sets. So if A and B are any two sets, then the difference A and B denoted by A minus B or A divided by B. Here a symbol divided by is used to denote a difference of a set. For example, A minus B equal to set of all X such that X belongs to B and X belongs to B. And similarly, B difference A means X such that X belongs to B and X belongs to A. Next, there are some properties for difference of two sets. Let us consider A set and B set. So first property is, let us take an A set and another one A set. So A difference A set, that is an empty. A difference A is equal to an empty. So second property is we are taking an set A and another set empty, which means that A difference empty is equal to A. And third property is we are taking a set A and we are taking a set B, which means A's difference B is a subset of A or A difference B is contained in A itself. And fourth property is we are taking a set A and set B, which means A difference B, A intersection B and B difference A are mutually disjoint, and it is an important properties in the difference of two sets. And the fifth property is A difference B intersection B equal to an empty. And sixth property is A difference B union A equal to A. Most of them are confused with the difference, both the difference, which means we are in a fifth property we are using intersection which is equal to an empty. But in a sixth property we are using an union. If we used union means it is equal to an set A. So next topic is complement of a set. Let A be an any set. The complement of A is a set of elements that belongs to universal set capital U, but it do not belongs to a set A. If U is a universal set, then the complement of A is a set U minus A and is denoted by A dash or A complement or A bar. So A complement is equal to U minus A. In solving a problem, we will use this part as a major. So A complement is equal to U minus A. In a problem, we will consider U as an one set and A as an another set. Every element in U should not be contained in A. It is a main concept of complement such that U and X does not belongs to A. It is a concept of complement. So next there are some properties like a different set. Now let us look into a properties of complement sets. So same like a difference of two sets. Here also we are considering a two sets, set A and set B. So first property is set A union A complement equal to U, and second property is set A intersection A complement, that is empty set, and third property is a universal set, that is universal complement equal to empty set, and fifth property is A complement the whole power complement is equal to an A, and sixth property is if A and B are two sets, then A union B difference A is equal to B. Next we are going to see about a Venn diagram. So first of all, what is Venn diagram? So Venn diagram is a pictorial representation of sets. In Venn diagram, a rectangle is used to represent a universal set, and a subset of U is represented by a circles inside a rectangles. For example, let us take a set A equal to 1, 2, 3 and B equal to 3, 4, 5. Now we need to draw a Venn diagram. For drawing a Venn diagram, it's very simple. First we need to draw an rectangular box and we are denoting it as a universal set U. Next we are drawing two circles and we are representing both circles one name. It's whether A, B or P, Q. It's based on the problems given in our question papers. So let's take here as a first circle as A and second circle as B. Now we are going to find out A union B. A union B means A and B need to be together in a same. So A part fully want to shaded and B part want to shaded fully. So it is called as a union, which in simple words we need to say means set A and set B should be needed to be colored fully or in the Venn diagram part. Then next we are going to see an intersection in Venn diagram. So same process, we are drawing in one rectangular box and two circles. In a rectangular box we are naming it as a U, and for two circles we are naming A and B. In our intersection we need to find a common point for both A and B, and we need to shade that common point. For example, in both circles we will find one common center place, we need to shade that. That shaded part is called an intersection part in Venn diagrams. So next is the properties of set operations. There are many properties. So first property is commutative property. So commutative property means A union B equal to B union A. In simple words we need to say means in a school days we have learned a commutative property, which means that 3 plus 2 is equal to 2 plus 3. Both will give a same answer as a 5. Same process, but here we are using in a set operation. A union B is equal to B union A. It is in the place of an union. It will be changed in an intersection. For example, A intersection B is equal to B intersection A. So next property is associative property. A union B union C equal to A union B union C. Set union is associative here. For example, we are considering any three numbers 1 plus 2 plus 3. 1 plus 2 plus 3 is equal to 6. Same in RHS part 1 plus 2 plus 3. So answer will be a same. Both in associative property, both LHS part and RHS part will be same. But we are showing a difference by its brackets. In intersection, A intersection B intersection C equal to A intersection B intersection C. So third property is a distributive property. So A intersection B union C equal to A intersection B union A intersection C. It is for an intersection distributives over union. So next is we can see union distributives over intersection. So A union B intersection C equal to A union B intersection A union C. So next let us see a very important topic in set theory, which means De Morgan's law. So let us see De Morgan's law for set difference. So we are considering a three sets. For any three sets A, B, C, we have A difference B union C equal to A difference B intersection A difference C. In a difference place, I have mentioned here as a divided symbol. Otherwise, we can use A minus B. Both denotes a difference. And second property is A difference B intersection C equal to A difference B union A difference. So let us another property for an complement. De Morgan's law for set of all complementation. Let U be an universal set containing set A and B, then A union B the whole dash equal to A dash intersection B dash. And second is A intersection B the whole dash equal to A dash union B dash. First property in LHS part we are using an union. So in RHS part we are using an intersection. In a second law we are using an intersection, and in RHS part we are using an union. So this De Morgan's law of set difference and De Morgan's law for complementation is a very important topic in theory. Next topic is inclusion and exclusion principle. The principle of inclusion and exclusion is a method of determining the number of items in the union of two finite sets. When solving a pairing and probability problems, this is used to find a counting method that ensures an object is not counted twice. It is used in combinatory to calculate a cardinality of a union set. So let us consider the following two finite sets A and B. The principle of inclusion and exclusion formula can be represented as follows. So N of A union B equal to N of A plus N of B minus N of A intersection B, where N of A union B equal to total number of elements in A union B, that is cardinality of set A union B. Next, N of A is equal to number of elements in A, that is cardinality of set A. Next, N of B equal to number of elements in B, that is cardinality of set B. Next, N of A intersection B equal to the number of elements that are common to both A and B, that is cardinality of set A and intersection B, that is A intersection B. Suppose we are taking a set A, B, C or a three set, then A union B union C is finite and it will be represented as N of A union B union C is equal to N of A plus N of B plus N of C minus N of A intersection B minus N of A intersection C minus N of B intersection C plus N of B intersection A intersection C. Thank you.